Hey students, Mr. Danahauer here. Good to have you today. Sorry I'm not with you. Today we're going to be doing a short lesson on phases of matter. This is a critical concept, a really important concept in Earth system science and really everything, chemistry, physics. Phases of matter is a fundamental concept. You probably have learned about phases of matter in the past and have some good background knowledge of it because you interact with all phases of matter every day. But we're going to dig in a little deeper today, get a little bit more in detail about these different phases. We'll also talk a little bit about phase changes. So again, in all of our Earth systems and really all of science, phases of matter is a fundamental concept because it helps us understand how matter behaves and why it behaves that it does. It helps us to understand density, other physical properties of matter. So it's really a key concept, and we're going to tie it into all of our different spheres, the geosphere, atmosphere, hydrosphere, and biosphere, as we walk through this class. In order to interact with our simulation and get some information down, you should have this phases of matter notes sheet. This is linked on Google Classroom, but you should also receive a paper copy. We're going to be jotting down some information on here. And we're going to be using this PHET simulation to help us understand what's going on with these different phases and phase changes a little more in depth. So just to orient you, the first thing we're going to do is just look at an example of a solid, liquid, and a gas and get some information, some very general information about those. So to access the PHET simulation, you can either Google PHET states of matter, or you can come to Google Classroom and find it linked here in our states of matter. And we're going to click on that. Should open up right away and go into states. And now you can see that we have an example here of a solid. All right, and on this side, we can choose different particles. When I say particles, I mean like an atom, or in this case, like oxygen. The particle is a molecule, two oxygen atoms together, or water, H2O, that's a particle of water, one molecule. So when I say particle, that's what I mean, an atom or a molecule. And down here, we can choose solid, liquid, gas, and we have the ability to add or take away thermal energy here as well to see how these phase changes work. All right, you can see temperature scale up here, and that's what we'll be playing with for now. So the first thing that I want you to do, and I'm going to help you with the first one, solid here, and we'll talk through that, is jot a picture of each of these different phases, like what they look like in the simulation here. Draw those and be sure to show the particle spacing, which I'm going to talk about in just a second. So you can draw those in just a second. First of all, the spacing is important. So when we talk about a solid, liquid, or gas, in general, we can come here to any solid and see that the particles are touching. All right, that's what we want to see here. If we move to a liquid, you can see that the particles are also touching each other. There's a little more space because they're wiggling around a little faster in a liquid. And every now and then we get one that vaporizes, a neon here that vaporizes and gets into the gas phase. But in general, I want you to focus on the area at the bottom of the container here, and that the particles, again, they are touching. And that is not true for a gas, right? So we're going to jot those down as we move forward. I'm going to give you time to work through each of these phases and jot notes down so you don't have to get it all right now. But if you want to get some of that while I'm talking, you can. So the next thing, after you've drawn a picture and discussed what the particle spacing is, and keep this short. This should be a really quick reference for you. It doesn't need to be long sentences. For the particle motion, how are the particles moving? Are they totally still? Are they vibrating but stuck in a place? Or are they bouncing all over the place? So just make observations as you go through these and see what's the particle motion like? Again, using short descriptions for each of these. Okay. Particle energy, so the more energy the particles have, the faster they're going to be moving. And we're talking about thermal energy here. So all you need to do is look how fast are the particles moving. And I want you to just do a comparison between solid, liquid, and gas. High, medium, and low energy. Okay. Faster they're moving, the more energy they have. That would be high. Slow moving, less energy, low energy. Then we want to look at the shape. How does the solid, liquid, or gas what shape does it take? Is it a fixed shape? And you probably don't need to use the simulation for this because you interact with these materials all the time, solids, liquids, and gases. Just think of water. What's the shape of ice versus liquid water versus water vapor that's in a gas? So jot that down. And then the density is one that may be a little bit harder. We haven't talked about density. That's for tomorrow. And so we'll be looking at a little bit more detail about density. But basically for now, for these notes, for the density section, just note if it's high, medium, or low. So if the particles are as close together as they can be, like in a solid, we're going to write high density. Okay. And now again, I just want to make this clear. This is for each individual substance. So if I have solid neon, the density of that is going to be different than solid water. You can see the particles take up more space. And there'll be some questions about that a little bit later as well. Okay, so I want you to use the simulation to get your pictures drawn and talk about these characteristics for each of the different phases. And we're going to take about maybe about 7 minutes to complete that. So we'll pause the video, give you a minute to use your computers and the simulation to do that, and then we'll come back together. Okay, now that you've had a chance to fill out the notes and get some general information about solid, liquid, and gas, we're going to move into phase changes. Also, if you weren't able to get some answers on this, feel free to talk to each other. This is a great time to collaborate with your table partners or other people in the class and make sure that you agree on these notes because you are going to be using them for assignments later. And if you have questions, of course, when I get back, I'll be happy to answer those for you. So let's talk about phase changes. In case you don't know what a phase change is, anytime a substance goes from one phase to another, we call that a phase change. And so an example would be like if I had water, the other night I was boiling some noodles for macaroni and cheese, and I had to put some liquid water. And as soon as it started to boil, it was going from a liquid to a gas. So a couple of things that I want you to be aware of for this is, first of all, what are the names of the different phase changes? You can see we have 6 of those that we use in general. And for each one, we want to understand, like, do we need to add energy? And that would mean the substance that's going through the phase change, the substance we're working with, is absorbing energy. Okay, it's taking in heat energy. And that would also, another way to think of that would be to heat it up. So if you want to put a little note above absorb energy, you could put a note that says heat up. So if I have to heat something up for that phase change to happen, it's absorbing energy. The opposite of that would be releasing energy. So if a substance needs to cool down, that is the same as saying that it's releasing thermal energy. If I put my ice cube tray in the refrigerator, probably the freezer if I want ice. So if I put it in the freezer, it's releasing energy from the water, and eventually it's going to change phase to become solid or ice. All right. So you could put a little note here that just says, cool down, or something like that. So you make that connection. All right. So take a few minutes in this simulation and play around with heating things up and cooling things off so that you can see how these phase changes take place. Also note if you play around with different substances. For example, I have neon here. If I change this to water, all right, the temperature of the phase change is going to be much different for water than it is for neon. So that's another thing you might want to play around with for a few minutes. Okay, so I'd like you to take about 7 minutes to complete the phase changes section of this diagram and pay the most attention to this section down here where you're saying what the 6 different phase changes are and if they're absorbing or releasing energy. We'll pause and come back together in a moment. Okay, now that you've had a chance to play around with that simulation and learn a little bit more about phase changes, I just want to give you a couple of examples of some of these and clarify a few things. So when we look at the phase change diagram, which by the way, you will see this on tests and quizzes where I might just have numbers for each of these arrows and say, what's this called? Does it absorb or release energy? So that's a good thing to put a star next to, or just note, like, you need to know this stuff for sure. Okay. So you guys, I'm sure, have heard of melting and freezing, maybe condensation, probably, especially when we talk about condensation in the water cycle when water vapor turns into cloud particles. And then vaporization, you may have used the word boiling for vaporization, and that's okay, but vaporization is a more accurate term when we're talking about going from a liquid to a gas. Okay. Sublimation, maybe one you haven't heard of, or you've heard of it but didn't know what it was. That's anytime a substance goes straight from a solid to a gas. A really classic example of this is dry ice. If you've ever had an opportunity to play with dry ice before, um, that is a solid carbon dioxide. It's very cold. I don't remember the exact freezing temperature for carbon dioxide, but dry ice is frozen carbon dioxide, just like regular ice is frozen water. Dry ice does not exist in the liquid phase. Carbon dioxide does not exist as a liquid at our current atmospheric pressure. It has to be under much higher pressure. So whenever we stick that on a table, or it's in a cooler or something, eventually it's going to go from a solid straight to a gas. It's going to skip the liquid phase. We call that sublimation. Sublimation. All right. And snow up in the mountains, actually a lot of snow, instead of going from a solid to a liquid, like we see here in melting, a lot of it actually sublimes. It goes straight from a solid into the atmosphere as a gas. So it's kind of like evaporation from a solid, but it's not really evaporation, because evaporation is from a liquid to a gas. It's another form of vaporization happening at more of like a room temperature. And the last one that most people don't really know about is deposition. Deposition is the opposite of sublimation, and that's when we have a gas that goes straight from a solid to a solid. So if you ever in the wintertime, which we're slowly creeping towards winter here, our days are getting a little bit shorter. It might be cooling off, even though we had some heat days, but hopefully we're going to get cooler. If you ever have to park out of the garage on the street, if you're not driving, maybe you've just witnessed this getting rides from your parents. But oftentimes, what do you have to do in the morning before you can drive away on a cold morning? You have to scrape the windshield, right? It's annoying, but in order to be able to see and safely drive, it's important. So what's going on there is not actually water, liquid water freezing on your windshield. It's the process of deposition. So water vapor in the air on a cold night is going to hit that cold windshield and go directly from a gas phase to a solid phase. And that's why it kind of sticks in a layer on your windshield through the process of deposition. So those are a couple of examples of phase changes that you may not be as familiar with. Okay, for the last part, I want you to take a few minutes for this challenge and application, and just see if you can fill these out. You may or may not be able to get the answers on these, but we'll come back together in about 4 minutes, and let's do 5 minutes and chat about these. Pause, and we'll come back together. Okay, so if you had a few minutes to look these over. Water is an interesting phenomena. So I want to come back to our states of matter here, and I'm going to click on water and change it to a solid phase. All right. What do you notice when water is in the solid phase? It makes these kind of ring-like structures. I'm going to cool it off a little bit more to slow them down, but it makes these ring-like structures. So you may have experienced when you take, let's go back to liquid here, liquid water. Look how the particles are touching, right? Every now and then we may get a molecule of water that evaporates. We'll see if we get a little bit of evaporation here. I'll heat it up a little bit. One's trying to escape. Anyway, whenever we take liquid water, okay, which the particles are touching. Oh, there's a vaporized water molecule. It had just enough energy to escape those hydrogen bonds of the other water molecules. When we go from a liquid to a solid, okay, I'm going to cool this off, and I want you to watch what happens to the spacing between the water molecules. Okay, we'll cool it off. And look, it's expanding, right? Because of the way that hydrogen bonds occur between water molecules, they form a ring-like structure whenever they become a solid. Most materials become more dense when they become a solid. Let's come back here to neon. Okay, I'm going to go from a liquid and I'm going to cool that off. All right. And we can start to see the particles are getting a little bit closer to each other. They're still touching in both phases, solid and liquid, but they're getting a little closer. They're becoming more dense. That's normal. Most substances are more dense in the solid phase than the liquid phase. But water behaves weirdly. So again, when it's a liquid, they're touching, it's more dense, and it begins to expand when we cool it off. If you've ever stuck a soda in the fridge, like Pepsi or something, you're like in the freezer, I mean, and because you want to get it cold, right? It's sitting in the box, and like, I need to get this cold. I'm thirsty. It's a hot day, and you put it in the freezer, and then you go about your business, and you forget about it. What happens? The thing explodes in the freezer. Hopefully, it doesn't. Every now and then, the can will just kind of expand, and it'll retain it. But I've cleaned up many exploded sodas out of my garage freezer. Not all my fault, but some from my kids too. But anyway, that's a great example of the water in that soda freezing and expanding and basically breaking the container because there's not enough room, and the pressure builds up and it explodes. So that was a long explanation, but um, why does water break the density rule? Because it expands whenever it freezes. Most substances are not like that. Okay. The next one about your daily routines, I'm sure you can think of many things that have to do with phases and phase changes. And one example that I can think of that I, deal with often is you take a shower in the morning to get ready to come to school, and you go to look in the mirror and it's all fogged over, right? Well, we've got a great phase change going on there. We got warm water in the shower; it becomes water vapor in the bathroom, and then the mirror is colder, and so as the water vapor hits that colder mirror, it condenses into liquid water again. So you have that fog on your window, on your mirror. Sorry. Okay, last one, and we're not going to talk about much, but plasma. Plasma, we don't find that on Earth very much. It's not common because it needs a lot of energy. In order to get something to become a plasma, we're basically putting so much energy into it that the atoms start to come apart. They lose electrons, and that takes a ton of energy. So can you think of in our universe where are places where there's a lot of energy? And if you said stars, that's a really good example, right? We get a lot of plasma in our sun, which is a star for our solar system, and other stars, there's a lot of plasma. So plasma is out in the universe a lot because there's a lot of energy out there from things like fusion, but there's not a whole lot of plasma on Earth. One place we do see it on Earth, do you know what it is? When lightning strikes. Lightning, of course, has a lot of energy. Hopefully you haven't been too close to lightning strikes. But when the lightning strikes through the atmosphere and interacts with the nitrogen and oxygen molecules, it can split those apart. There's so much energy, it can actually cause a plasma to occur just for a short amount of time, and then the energy dissipates. Okay, um, that's all for phases of matter. You're going to have an assignment to do with this now, and so I will bring that up and show it to you. This is called the Phases of Matter spider web. Now, this is a little bit more intense than just um, your typical like matching. All right. Here on this side, we have phases and phase changes. So we have all three phases, not plasma, but the three main phases, and then all of the different phase changes. Here we have descriptions. This is important. Number one, you're going to use straight lines. Okay, so I've got some rulers in the back cabinets underneath the drone if you want to grab some rulers. And you're going to connect anytime something over here describes something over here, you're going to draw a line from that thing. So you're going to have more than one line coming from these often, and more than one line going to these. As you draw your lines, you're going to cross out letters. That's why it's important that you do straight lines. Okay. You're going to cross out letters. When you have all of the lines correct, you should have some recognizable word or phrase down here that you should write down. Okay, and it will make sense. It will not be gibberish. So if you come up with gibberish, you probably did something wrong. When you're doing this, if I remember correctly, I'm going to make a note up here. There are 19 lines. Okay, so you should have 19 lines total. Also, if it says phase, then you're going to connect it to solid, liquid, or gas. If it says phase change, you're going to connect it to one of the phase changes. All right, so there's already some clues there. If it says phase, you're not going to connect it to a phase change. And if it says phase change, you're not going to connect it to a phase. So that'll help you out a little bit as well. Right. So we're going to take the rest of class today to work on that, and I'll get that from you tomorrow and answer questions that you might have. Actually, I'm going to get that from you when I come back, and then I'll answer questions. Okay. All right. That's all for today. I hope you learned a little bit more about these amazing phases of matter. While it may not be exciting to look at it this way, we're going to really connect it to a lot of different things in Earth system science. Have a great day and Sco Ridge.